Okay, so this time it actually works. I'm actually really excited about this. I didn't blatantly go in recording and not being able to record. So that's a good sign. I think I have hope for this one. Anyways, hi. Today we're gonna be graphing rational expressions, rational function thingies onto this graph over here that I drew. Don't mind its quickiness. It's okay though. So this is the problem that has been afforded to us, and it looks very interesting. It is very interesting, but don't worry, we're gonna solve it. And how are we gonna solve it? With a set of steps that I have learned in the course of a day, because it is the 11th by the time you're hopefully getting this. Hopefully. So, what we're gonna do first is we're gonna work on simplifying this function-esque expression because honestly, this is a lot. It's giving quadratic right now, and we don't really want that, or at least on the top. At least on the top. So, right, simplifying this, we're basically going to be looking for factors, and I do kind of already have this pre-planned, but basically you want to factor out this expression over here, and it gets very complicated, and finding what adds and multiplies to give you these two numbers, but then again we have that 2 that we have to be aware of, so that would turn out to be something like 2 with x plus, not minus, plus 2, and then x plus 3, if I'm not mistaken. X plus 3. Okay. And then for the bottom, that's going to be pretty simple. That is going to be x plus 1. Don't like how that x looks. X plus 1, and then, oh gosh, x plus 2. And even then, we still aren't really done because we have this 2 right here. And the thing about that 2 is that it actually needs to be distributed because, we can't really leave that there. That's not gonna fly. So this needs to go into this and this. Yeah. I would think, I'd hope. It needs to go into both of them now. So that is going to give you, oh, and then right, we have to simplify this too. And then that is going to give you, like 2x. No, actually, wait, I messed it up again. Wait, you do it one at a time. Okay, so you're gonna get 2, 2, and then, no. You're gonna get, just going into all of this, 2x plus, oh gosh, plus 6, over x over 1. Boom. My brain did the math. Easy. Anyways, moving on. Now that you have this simplified version, which I did kind of, go into a lot, but it's okay. We're gonna, we distributed this and this, and, yeah, it'll be fine. It's this and this, yeah. Anyways, so, funny story. Oh, wait, yeah, funny story. The thing about these rational expression thingies is that we want to look for things that cancel out. And now realizing it, that's the mistake I made. Don't worry about it. Everything is fine. These actually cancel out. Teehee, if you didn't know. Yeah. maybe let me clarify this for a minute. I did make a mistake, but everything is gonna be fine. So these two cancel out. That is the step that I just missed. Mainly because like whenever you have the same like expression thingy-mabob in these parentheses, they cancel out. So x plus 2 and x plus 2, they do cancel out. So that wouldn't be distributed over here. Yeah, that line wouldn't happen. There we go. It just be distributed into this right here. And then 2 times x, that's 2x. And then 2 times 3, that's 6. And that's how you get this, okay? There we go. And then, yeah, and then bring this down. That makes a lot more sense. Okay, I did that. Sorry about the confusion. Anyways, now that we have all of that done, let's clear this up just a bit. And by clear it up, I mean let's get rid of most of this because we just want our simplified expression down here. Okay, and then let's bring this up because we're going to use this. Now, what we need to do a couple of things actually. We need to find the whole. And wow, Raya, you really just threw it away. Okay, I'll bring it back. So our whole is going to be our common factor that's in both of in both the numerator and the denominator. So that'll be our 2 plus x, but just so you guys know, it is not a positive 2, that is actually a negative 2, because that's not in its correct form. But anyways, now that we know that our whole is going to be, hold on, x, plus 2, whoopsie daisy, x plus 2, there we go. Now we can work on finding, like, our actual, what do you call this? It's like the whole, or the part where the number, like, doesn't exist on this graph. And let me actually just draw that symbol just so there we go. Okay, it'll look something like this, and it's not actually a spot on the graph. Okay, it's a hole, like a hole in a piece of paper or a hole in like a straight line. That would be this, and that's what we're looking for. And basically the way to find that is by substituting this common factor into this problem down here. So when you substitute, I have to write all this out. When you substitute 2 times negative 2 plus 6, and then negative 2 plus 1, you will get the number, hold on, you will get, as soon as I can do this, negative 2, comma, 2, negative 2. There you go. Interesting looking 2s, but it's completely fine. Anyways, now that we know all of that, that is good, because now, we have to actually use this up here to find, no, we have to figure out, like, the thing. The thing being, oh my gosh, the thing being the thing that basically says, when we take our 2x plus 6, we want to set that equal to 0, and we want to figure out what's the number that makes that exactly 0, which, again, I did do the math, would be negative 3. So keep that in mind because we actually do need that. And then moving on, so let's move this up. We have to worry about putting this all on a graph next, okay? So now we need to find our vertical asymptote. And you find this by, well, that's like technically what I was talking about. Finding it by setting x equal to 0. Yep. That would give us negative 1. So when we talk about our vertical asymptote, we need a vertical line that's not very straight. A vertical line, okay? But it's going to be dotted. So let me pick a prettier color because colors matter. -1. Oh gosh. Okay, time to try and draw a straight line somewhat. So we know that we're going to be plotting somewhere down here, and then our horizontal asymptote is going to be this 2 common factors right around here. And I'm sorry, I should be plotting these numbers, these -3s and these 2-2s, because these actually go on the graph, but I'm not gonna do that just yet. So moving on from that, now that we know where we need to be plotting, and we know that our intersection thingy is probably going to be somewhere around -3, and then we have to find the other one. Next what we're going to do is we're going to take our vertical asymptote and basically like set up our little grid. That's what I like to call it. It's just a little grid, okay? Let me move this up if I can. So we want to have a set of numbers for x and y, no, just x, to plug into this equation right over here to find our dots. And since we're working with a base of -1, which is going to be our vertical asymptote, that's where we start. And then we want to pick numbers like going up from there and also going down from there, right? So -2, -3, and I don't have enough room. Let me delete this line, and then we're gonna do -4. You should probably do at least 3 different numbers for these. And then going on up, we have 0, 1, and 2. Tiniest one ever. But basically, when you substitute or sub in all of these numbers, they should give you your points. And I did do that beforehand. So, just to make things quicker, so it's substituting -4 into this equation will give you 0.6, but that's also equal to around 2/3. So 2/3, just to make things equal. And -3 is going to give you 0. And then -2 is going to give you -2, which is also going to be one of the points on the graph. -1 is undefined. And 0 is going to give you 6. 1 is going to be 4. And 2 is 3.3 equals 10/3. So, now that we have our points to plot onto the graph, I did do this beforehand, so keeping this in mind, we're gonna have one at -4, and 2/3, so somewhere around like here. Actually, let me use a different point color. So somewhere around there. And then the next one being -3, 0 is going to be right here. Just right on the x-axis. And then -2, 2. This one is going to be our hole, as we've established. So let me use a different color for this. And also, let me make sure that it is rounded. And there we go. That is our hole. Moving on from that. Okay, there we go. Next, we have our 6. Yeah, since 1 is undefined and that being 0, yeah. But we have 6, so 1, 2, 3, 4, 5, 6. That is very high up. And then 1-4, which is going to be right over here. And then our 2 10/3. So right around, I'd say like past the, well, it is past the 3. So here. Yeah, somewhere like that. So now that we have our lines, we can just draw what these two would look like. So, oh, that's like a really thick line. Hold on. So, touching through all of these points. And then I have to make that straight. Okay, because it approaches it, it never touches it though. And then boom, and that's what it should look like. So, I think that was honestly pretty easy. It shouldn't be too difficult to do. We know that our intersection is going to be our -3 and our 6. So, yeah. There's not much to it. And, yep, math is Candy Crush. That is all